Bonjour. Hello, welcome to this French-American Innovation Days on Physical Science and Engineering Solutions for the Environment, or Green and Blue in short. On day one, it was on Monday, we had a session on energy. On Tuesday, we had a first side event, a biomimicry innovation workshop where we used Biomimetic tool to propose us strategies of natures, and we were trying to map them after this brainstorming using 7 vortex tool. I will probably show you a short video later on during the break or maybe at the end of this session. And on day 2, it was on Wednesday, we had a session dedicated to water and the environment. Yesterday was a Café des Sciences organized by our colleagues from Chicago. And today is day 3, the last day of these French-American Innovation Days, and it's dedicated to resilience in the built environment. I'm Vernoux-Thélot, attaché for science and technology at the Embassy of France in the US, assisted by Linda Amici, and we are with our co-organizer, Larry McKinney, Christelle Roger, and Kalina Raskin, who will give us a perspective on biomimicry at the end of the session. We are very happy to propose you these different talks. Today's moderator is Chloe Demrovsky, President and CEO of DRII, Disaster Recovery Institute International. It is a nonprofit organization that helps entities to prepare for and actually recover from disasters. Chloe has been a commentator for BBC, Bloomberg TV, USA Today, among others. She's also a contributing writer at Forbes, an adjunct professor at NYU, and a French-American Foundation Young Leaders. Chloe, the floor is yours.
Merci, Renaud. Bonjour à toutes et à tous. Good morning, everyone. I'm so happy to be here with all of you. Just going to take a brief minute to share my screen so you can see my presentation. We're talking about a very important subject today that is near and dear to my heart. I want to talk a little bit about my origin story, about how I got into all of this and why. So I started as a temporary employee at DRI 13 years ago, and then became CEO a little less than 10 years later. It was a story that I never expected, a journey I didn't expect to be on. But at first I went, okay, well, this is sort of interesting. Helping organizations prepare for and recover from disasters is a noble cause. It was a nonprofit. We dealt with organizations from all over the world and every possible sector, from the government, from the private sector, nonprofit, hospitals. And but it was a bunch of technical specialists who spoke a language that I didn't understand. I didn't come from a technical background. I'm not an engineer. I didn't study the topic. I'm much more of a generalist, but I'm curious and I'm not afraid to ask dumb questions. So forgive me in advance, fellow panelists, if I ask you dumb questions after your presentation. I find sometimes they can lead to really wonderful responses. And so it was at our conference in 2012 that we actually hosted in New Orleans, and we had a volunteer day before that. And we were rebuilding homes with Habitat for Humanity. And I saw that the devastation from Hurricane Katrina 7 years later was still just completely devastating communities. We were still rebuilding homes. There were homes that were just condemned everywhere. You could still see the marks. You could see the mark of the water. And that was just a very, very sad thing to see. Then a year later, Hurricane Sandy hit my own home of New York City. And I saw it firsthand, that immediate devastation, the destruction. You know, immediately I was going out to some of the areas in Staten Island and Brooklyn that were very hard hit by the storm, where there was just a ton of devastation. And so I'm looking forward to hearing how oysters can help protect us from some of that storm surge and the devastation with our first topic. We know that this is continuing this year. We saw Hurricane Ida come through very unexpectedly, and it wasn't storm surge this time, it was record rainfall in a very short amount of time. And yet we still saw infrastructure failures. There was a viral video of the 28th Street subway station with a waterfall coming through. This is a classic example of what's called hard infrastructure failing. So I'm pleased to see that we're going to talk about a unique and innovative approach today about how we can be more resilient. before I continue any further, I want to talk a little bit about what resilience even means as a starting point. So according to the Oxford English Dictionary, it's either 1, the capacity to recover quickly from difficulties, or 2, the ability of a substance to spring back into shape. And I think both of these concepts are very important when we talk about resilience in the context in which we are. Recovering quickly, coming back faster, not that 7 years after Katrina, for example, and also springing back into shape, which is a wonderful concept, except when you talk about climate change. And the problem with climate change is that things are changing, right? We have different needs. So if we just bounce back to where we were before whatever happened, if that same thing happens or worse, again, we'll end up right in the same place. So instead of just bouncing back, wouldn't it be better if we could build back better? If we could revise this idea of hard infrastructure that isn't actually adequately protecting us, and maybe think of a different approach. And so I'm really excited to learn more about some of these approaches that draw on nature a little bit. And also the fact that we're going to talk not just about mitigation of the effects of climate change. We'll talk a little bit about that, that's preventing the potential effects from occurring. And that's a really important component of the conversation, of course, but I would say that it's dominating the conversation. So that's conversations about, reducing the levels of carbon in the atmosphere, about moving to electric cars. Those kinds of conversations are about preventing the effects from getting worse. A lot of what we're going to talk about today is more about adaptation. So dealing with the effects that are already upon us. It's not a conversation people like to have, but some effects of climate change are inevitable. So we really need to adapt, and we need to think about adapting now if we're going to be able to get through this effectively. So how are we going to discuss this today? We have 3 different topics, and they're very exciting. The first one, as I said, is about oysters. We're going to talk about underwater cities. These creatures seem to have robust lives, an important role in our ecosystem, not just on my plate. I love them at happy hour, but we're happy to have them populate our cities as well. Topic 2 will come above the water and talk about cities themselves, and hopefully some ways in which we can think about preventing some of those flooding effects and other effects of climate change with some more innovative approaches drawn from nature, using things like biomimicry, which is such a lovely word. And then topic 3 is going to broaden that even further. So we'll talk about some other innovative socioeconomic solutions for climate resilience that will just build on the conversations that we've already had. So, and then after that, we will gain one additional perspective at the end of the seminar with remarks by Kalina Raskin, who is the CEO and founder of the Biomimicry Center of Expertise, CEEBIOS, in France. I don't want to take up too much of the time with context. I want to jump in and make sure we have enough time for discussion. So I'm going to jump right into our first panelist and turn the floor over to Jennifer Pollock, who is the chair for coastal conservation and restoration at the Harte Research Institute, USA. Jennifer, you have the floor.
Thank you. Okay, is my screen visible? The presentation visible?
It is.
Great. Okay, thank you so much. Well, first, let me introduce myself. My name is Jenny Pollock. I am the chair for coastal conservation and restoration at the Harte Research Institute here at Texas A&M University Corpus Christi. And I'm also an associate professor of marine biology. And I'm just going to take this time to talk a little bit about some of the work that we've been doing with oyster reefs and trying to recognize their biomimicry effects to help protect shorelines by using oyster reef restoration in such a way that we can create living seawalls. Just a short background about why we work on oysters and why oyster reefs are important. These organisms and the reefs that they build provide numerous ecosystem and economic benefits. So the way that reefs build is that the younger generations of oysters, the larval oysters, attached to the shells of the older generations of oysters. So over time, you have sort of a framework or a scaffolding of the older generations of oysters and their shells that are capped by a living veneer of oysters. And that structure then builds itself over time into a three-dimensional complex habitat. So that three-dimensional habitat then can do things like protect shorelines from erosion by interrupting wave energies that are moving across the bay, for example. The oysters themselves are also suspension feeders. And so oysters, while they're feeding, are actually cleaning and clearing up the water in which they live and transferring things like excess nutrients, heavy metals, etc., from the water column to the sediments and resulting in this clearer, improved water quality. Those reefs also provide habitat. So we know when you have oyster reefs, you have enhancement of biodiversity. And we know that biodiversity is good for a whole number of things, including medical research, as well as supporting some of the recreational activities that occur out in our coastal environment. And one of these being fisheries, support for fisheries. So oysters themselves are both a recreational and commercial fishery that generates a lot of economic activity for coastal regions, but also supports things like recreational angling and tourism, where folks can go out onto the bay and target these areas for recreation. So the goal of this project is to construct reefs that can help mimic the services provided by natural reefs. So we know that shellfish reefs globally have experienced severe declines in the last century plus, and we're trying to find ways to both restore the habitat that's been lost, but also make sure that we are providing and replacing those essential ecosystem benefits that we rely upon from these natural habitats. So I would like to share a case study with you of a restored reef project that we have been working on for several years, and it's still in process in St. Charles Bay on the Gulf of Mexico coast of Texas. So I don't know if you can see my cursor or not, but down here towards the bottom of the screen, you can see the larger map where we have the Gulf of Mexico, Texas, and it's here in the Texas, what we call the Texas Coastal Bend. Over to the right side of your map here is a state park called Goose Island State Park. It's a park that's experienced incredible amounts of erosion over the past decades. You can kind of see this by the sort of scooped out shape of the shoreline. This was an area that was identified to us from state park staff as having desire for natural solutions that could help slow erosion and also provide additional economic and ecological benefits to the park. So we decided to restore this reef as a living seawall. What you're looking at here, these rectangles, each are a ridge, if you will, of restored oyster reef. All in, this is 8 hectares of oyster reef complex that are being restored. This is the filled in polygons here are the 17 reef ridges that have been constructed to date. So they're each 10 meters by 40 meters and 1/3 of a meter off of the bottom. And the ones that are not filled in yet will be constructed in the spring. So there will eventually be 32 reef ridges in this location. And the idea, of course, was, as I said, to protect this eroding shoreline, but also to restore lost habitat and ecosystem benefits. I wanted to just show a quick video. This is the shoreline that you're facing now. All of these dark ridges that you can see that are marked by posts in the water, those are the reef ridges that you can sort of see, those dark shapes. So you can sort of see how it's oriented. And there's actually a wade fisherman out here that you can see in the video. And how these reef ridges then will protect the shorelines from wave activity and current activity moving across the bay. These were constructed using recycled oyster shells. And so the way that you can restore oyster reef in these areas that are not larvally limited, but are just substrate limited, is essentially find the right places and the right time of year to put suitable hard substrate back down on the bottom. And we have enough natural recruitment of oysters within the area that then they have attached to these reefs and populated them and grown to larger sizes. So let me just stop this video and go to the next, because I wanted to show you one other video just showing you the success of this reef. So this is now diving underwater, and you can see that you really would be hard pressed to see any of this, the substrate that we put down. And this is really just a, this is better than I can describe to show that these constructed reefs are able to mimic or mirror some of the ecological benefits that we expect from natural reefs. So you can see really high densities of oysters, you can see bryozoan, you can see algae, you can see different size classes of oysters here. So really demonstrates the ability of these reefs to provide those benefits. So this is my last slide. Just in summary, what we have seen is that these constructed oyster reefs can mimic the benefits of natural reefs. What we've seen is that when you create these reefs and oysters are recruiting and growing, that actually the protection benefits of these living seawalls should improve over time, because they will grow, have more vertical relief, more complexity that can help break up wave energies. And this living shoreline approach is something that's still kind of being developed in a lot of places. And as it's being developed, the benefit is that it really advances us beyond this traditional kind of gray, hard infrastructure approach that has a relatively short lifespan because they break down, whereas this is a living structure that can self-heal and can grow over time. Thank you very much.
Wonderful. Thank you so much for that, Jennifer. Thanks for kicking us off. I'm not going to ask questions of you right now because the two topics overlap wonderfully. So I'm actually going to ask the questions after our next panelist, and that way we can have a little bit more interactive engagement between all of us. So our next speaker is Evelyn Tickle, who is the founder and CEO of Grow Oyster Reef USA. Evelyn, the floor is yours.
Great, thank you so much. And Jennifer, that was terrific. And it sets me up pretty well. Can everyone see my, is my screen visible?
Mm-hmm.
Great.
Yes.
Okay. Okay, so hi, I'm Evelyn Tickle. I'm the inventor, founder, and now CEO of Grow Oyster Reefs. We're located in Charlottesville, Virginia, and in the Chesapeake Bay watershed, and most recently in Los Angeles, California as well. And I have my master's in architecture. This is my second concrete business, and I wanted to, when I originally established this, to do something environmentally positive with concrete. And my research has been in biomimicry for the last 20 years, and I've been pouring concrete for about 25 years as well. And so I looked to the oyster originally for its cementitious material that it makes in order to adhere itself to the back of another oyster shell. And I found the oyster in peril down approximately 85% in decline from earlier times, and mostly due to human intervention. And I decided I had some skills in place to be able to make a difference. So with that, I invented a what we call Grow CaCO3 concrete, which carefully matches that of the oyster shell, delivering early stage nutrition to the oyster, sending out chemical cues to the embryonic oyster to attract it to the artificial reef, which is built with, we have many products that feature the Grow Oyster Reef tile, and that you see here on the left-hand side of the page. And it is a 33-pound unit by 12 inches by 12 inches and weighs about 33 pounds. It has holes in the bottom that allow for seagrass plugs as well. It is built off of a bottom plate with vertical projections. And with my biomimicry expertise, I started looking at the oyster and the way that it forms itself into a natural reef, and found that it develops typically in clumps or groups, and uses amazing architectural skills such as buttressing and using horizontal shells as top plates and cantilevering out. And eventually these groups grow into each other. So developed this modular unit at about 12 inches in diameter, and emulated the vertical protrusions that the oyster needs, so giving the oyster a leg up or a jump start in order to develop its own reef. And so with that, the reef tile can make all sorts of natural configurations, and immediately when it is put out into the water, it forms a habitat for fish and other species even before the oysters are there. We've had the Virginia Institute of Marine Science, also known as FIMS, to do the testing on our product. We're growing a faster oyster within the first year in comparison to a typical concrete in one of our competitors' products. And we are having an average of 50 up to 100 oysters within the first year. And those results are comparable to some of the most effective artificial reefs within 5 years of time. Now, Jennifer's real curious about where your results are, so very excited about that as well. And we are using those, and all of our products are patent pending at this moment. And we are using the, I don't know how to, there we go. Oh, there we go. So what we are focusing on also are these wide reefs. Instead of doing a shoreline protection only at the shore, we are also looking to nature and understanding that it begins to attenuate wave energy much further out from the shoreline. And we're using the reef tiles that you see in the foreground. And this is from a proposal for DARPA, the entrepreneurial arm of the Department of Defense, who recently issued a call called Reefs to have infrastructure that attracts either oysters or corals as self-healing organisms to protect Department of Defense, and as we add civilian infrastructure. And so the reef tiles are laid down such as a blanket on the shoreline, almost like tide pools, to create that initial habitat, planted with seagrasses to further attenuate the wave energy and to as an intertidal approach to attract to sequester carbon, and then as a underwater approach, adding another product that we call the Reef Tangle, and that is a 33 to 36, it could be any size, spherical unit that is basically hollow and porous. It only uses 2% of the concrete. We make it with a material called concrete reef rope, and those interlock into thickets or archipelagos to begin to further attenuate wave energy, and provide amazing habitat for young fish and other species, as seen here in a close-up of the concrete reef tangle as tested and presented at the American Underwater Museum of Art on the earlier barren Gulf of Mexico floor. And it also is, it's off of the coast of Florida, off of Grayton Beach. Thank you. Okay, and that concludes my portion of things.
Okay, well, thank you so much for both of those wonderful presentations. So we got a question for Evelyn, and we'll kick us off with that one, but I'm actually going to broaden it to ask both of you a question that came up for me while I was listening to you. So the question was, tell us a bit more about the chemical cues to settling spat and how you mimicked it in your structure. And then the question that I wanted to ask you both is one, it seemed that there was the use of concrete versus the use of the oyster shell material in making this. So I want you to talk kind of about the pros and cons of the materials that you used in designing your product.
So since my speaker's on, I can jump in on this one and answer the chemical cues. So our concrete is a very clean concrete, and we are at about 75 to 80% calcium carbonate. The oyster shells approximately, it's higher than that, 85, 90%. And so what's happening on our products, and as we cure them, we're developing a calcium carbonate rich shell through a process of effervescence, which, and it sort of works like a Roman concrete as well. So it makes very close to an oyster shell on that. And that those chemical cues and that early stage nutrition is because of how it begins to, like that of an oyster shell, begins to interact with the water around it, hopefully acting as sort of a TUMS to begin to further neutralize all those excess nutrients in the water. And then I can stop here and then just join in the conversation. And I guess I would just say that we can we have reusable molds that we use, and we pour those in 2 minutes, and we are able to demold in 2 minutes as well. And our molds have about 1,000 products that they produce out of each one of the molds. So we are very fast in being able to do that. and to be able to get product in the water. And it's, so the process is very quick. We're growing a faster oyster, and which actually becomes a normalized growth after that first year. So that's very important in the predator proofing, and also to begin to jumpstart quicker reefs.
Wonderful, thanks. Jennifer, did you want to jump in and talk about how your process differs?
Sure. Well, I will say maybe first of all, so I was mentioning that this reef was built with recycled oyster shells, but that is a product that is really limited in supply. So we have our own local oyster shell recycling program here. And so we've been able to benefit from using the natural shell in building reefs, but that isn't always the case. So, you know, what Evelyn is talking about is meeting a need that is really in high demand right now. So we've actually looked at different types of materials for building oyster reefs. So we've looked at everything from, you know, concrete, I mean, just kind of off the shelf, we've looked at concrete washout from concrete trucks, you know, after they've completed a job and they have to get the concrete out of the truck, like using that concrete. We've looked at using limestone, river rock. We've even looked at crushed up porcelain from like residential tubs, toilets, sinks, and using that as a potential substrate. And when the oysters are substrate limited in the bay systems, they're going to attach to what they need is that hard structure. And so being able to provide that is kind of number one. We've seen that they will attach to a number of different things, but it varies. Like there's definitely a cost benefit analysis that needs to be done, like Evelyn is talking about, for any product that you were going to put into the water to see, does it recruit oysters? Do the oysters actually stay attached and grow? So a problem that we found with porcelain that's reclaimed from the residential waste stream is that it's glazed on one side. So you can imagine if something attaches to that, it's very slick and it's not going to stay attached. So there is definitely the need for the kind of the R&D side. But we need other things that we know are safe to put in the water for the oysters to attach to. Absolutely. It can't just be built off of reclaimed shells.
Well, on that note, we had a follow-up question from the audience. So has there been any research into the technical viability or feasibility of hempcrete as a material option?
I'll just jump in and say that I have a beginning partnership to test that. We use a very minimal amount of cement, and on the question of the intense carbon production of cement. So we're looking at substituting that out, hence kind of beginning to work with a hemp company, a hemp startup. And then also we're very, very low cement use. And then if you compared our products to that of a solid product, we work with this notion of porosity. So to also provide these gaps and these holes for other reef building species and other species that need the reef, such as the fish. And so if you looked at one of our spheres, for instance, the concrete tangle, if that was a solid product, as many of our competitors make, that would be, we only use 2% of the concrete in that, really focused on the surface where the oysters grow in a very, very high surface area so that they can grow all around our product. And then we still include those interstitial spaces for the other species. And so we think that that's really important. And as an architect, I've done a lot of study and research about the concrete that's on the shoreline. One of the things in the 60s that was a big deal is there's actually a porcelain toilet reef in Hampton, I believe, one of the earlier reefs. And so trying to make sure that we're looking at all these, before I started the business here, I looked at all sorts of other reefs and who was using what and for what reason. And then I guess I have a concern about the concrete, because a lot of concrete includes admixtures and chemicals for various reasons. And so some of that begins to sort of leach into the water as well. So I wanted to make sure that we're avoiding that and using best practices to begin to move into this field. So yes, I am looking at hemp.
Jennifer, what about you?
No, I mean, we really aren't on the R&D side like Evelyn is. So like I said, generally we're trying to build our reefs with recycled shells that we reclaim from local restaurants and seafood wholesalers. We have been able to use other recycled products like the river rock and the limestone and the concrete to help form the base of the reef if we need to, and then top it with oyster shell and just use it as something to keep the shells from sinking into the mud, you know, just kind of using it as a stabilizing material. But I will say that we have interest in all of this work, you know, like we are doing a lot of restoration work ourselves, and knowing that there are other options that are being explored out there is something that we are interested in learning about or being a part of kind of proof of concept testing. I will say that, I don't know, Evelyn, if you have tested your product in the Gulf of Mexico, but the oysters grow so much more quickly here than in Virginia, for example. So we usually see market size or 76 millimeter oysters, 3-inch oysters here in the Gulf of Mexico in 12 to 18 months, which is incredibly fast compared to the East Coast. And it would be interesting to test your product here and look at it versus some of the other reefs that have been built or some of the natural reference reefs. So
that would be great. Ours reached on that initial testing, and at that point I didn't have his, so I actually asked a chef to come in, a French chef, by the way, to come in and look at the oysters on the product and say, you know, are these commercial size, are these mature, you know, and how do they look to you as a chef that's had his hands in on a lot of oysters. And he was very pleased. So pulled those even at 9 months, and I had mature oysters at that point. So I would love to be able to test them, and would love to work with you, quite frankly, and be able to get some product in the reef tiles in the Gulf of Mexico. Sure. Because on the reef tangle, it was primarily what you're seeing, and not a lot of oysters. So it would be fantastic to have that opportunity.
Well, you're making a good sales pitch.
Let's do that.
Yeah.
So when you put whatever you've decided to design or build into the water, you're sort of leading into this conversation a bit, but like what happens, how long does it take, how does it develop, you know, what does that initial process look like? Maybe.
Well, as Jennifer was saying that, and please jump in here, Jennifer, with me, you know, the warmer waters, the oysters grow faster. And so, for instance, the warmer waters, as Jennifer was saying, you know, they grow very quickly, and that is ideal place. But oysters grow in all sorts of areas. They grow in very cold water. Also, Prince Edward Island oysters are some of the best oysters, I believe, and they grow very slowly. So the colder waters produce a much slower oyster. So I see ours as being very helpful in those colder waters as well, and such as Maine. And I'll just add another issue is that trying to develop oysters where there's no evidence of native oysters on the shoreline to produce those embryos, the products, the reef tiles are able to go into the hatchery and be seeded with small oysters we call spat, and then put out, which is a great thing to be able to do. And we have a project right now in England where we adapted the reef tile to have a bottom wedge that goes in between riprap or rock armor rocks. And Portsmouth is engaging in a 10-mile project 10 kilometers by 50 kilometers wide to protect their shoreline and their infrastructure. So we're piloting to see if we can get the native oyster that is so important to England and to France to be able to latch on by taking the top layer off that particular infrastructure and attracting oysters to be able to, you know, do all the amazing things we've been talking about today, the living shorelines, et cetera, and also to help stabilize that immense amount of money and structure that they've put in there. So that is a very exciting pilot, and also to keep away the invasive oyster in England and in France, which is the Pacific oyster. So that's very interesting because we kind of have to really focus on the native oysters.
And so, Jennifer, do you see a similar kind of timeline once it grows, and also for you, and then for Evelyn if she wants to jump in as well, like it seems like there's then a market for these oysters. Do they just like, is this a beautiful retirement community for the oysters, or did they end up with the chefs? Like how does that all work?
Yeah, that's a great question. Well, I guess I'll add to what Evelyn said and just talk about a little bit of what we do before we build the reefs, because I think she gave a nice description of what happens once the material is out there. But, you know, we typically are doing work to figure out where the best places are to put this reef, whether it's the shells or the tiles. I'm sure Evelyn's doing the same thing. And then what the best times of year are also, because as you know, if you've pulled anything out of the water, there's usually something attached to it, you know, could be a piece of rope and it's got barnacles all over it, whatever. So we want to choose the times of year where the oyster larvae are dominating what's in the water to attach. So that's what we would do in terms of the right times of year. And then in terms of the right places, we typically look at historical data from wherever we can grab it to figure out, you know, which places historically have had oysters over long periods of time or have the least variability. So they don't, you know, they're not there some years and gone other years, to kind of put our money in our best places. So that's one piece of it that I wanted to mention. And then the other part of it about harvesting was a good question. So actually in Texas, there's a number of projects now that are trying to balance ecological and economic benefits. So like the harvesting benefits with the benefits that the oysters can bring to the bays. And how they're doing that is doing sort of paired restoration. So you might have an area of the reef that you have created, designated for future fishing, and you may have an area of restored reef that you've designated sort of as a sanctuary reef, if you will. And so the idea is that by protecting one area of the reef, you are creating large oysters that are going to release larvae, you know, into the water column, and that those larvae then are going to be able to populate these areas of reef that are fished. So you can kind of protect the three-dimensional complex structure and those ecosystem benefits while also benefiting the adjacent fished reefs.
It sounds like a total win-win. I do want to bring this towards the resilience side a little bit, because both of you have talked about the Gulf Coast. We saw obviously devastation to Houston with Hurricane Harvey a few years ago with the flooding. Can you talk a little bit about how oysters and your projects can help with mitigating some of these effects? And also we're seeing a lot of devastating impact of flooding and water in all the wrong places around the Gulf of Mexico more broadly. So how do we prioritize?
Well, if you were to ask me, I would definitely say that oysters are one of the most economical and fastest ways in order to build resilience. They, you know, as we've been saying, they grow, you know, to maturity, at least in those waters, at 1 year. And they, correct me if I'm wrong, Jennifer, but they release about 1 million embryos at least once a year. So we're talking about mass production of oysters and in comparison to any other way. And then, you know, we're finding the seawalls and riprap to some degree is not very effective, has to be replaced over time. And as the waters are rising, one of the things that's happening is that these are just not working and the water is coming over the tops of these. And it's very difficult to add on to the tops of the seawalls and to begin to change them. It's very costly to begin to add the riprap as well. And the oysters do this naturally. So they're going to grow upwards as the water rises. They're going to diminish if during times of, you know, drought or whatever, which doesn't happen very much in the ocean. But so I feel like they are an amazingly economical and fast opportunity to be able to, you know, keep up with the rising waters, to be able to protect the coastlines. And this was the oyster's job for, you know, for thousands and thousands of years. And, you know, the human devastation that we have done to the oyster reefs has put us into sort of this problem.
Yeah, I think that's a wonderful advertisement for biomimicry and why we're looking at these types of design as well. We are totally out of time, but I wanted to just give Jennifer like 30 seconds if you wanted to.
Sure. Okay, thanks. Well, I will say that that reef that I showed the video of in St. Charles Bay, we completed the first phase of construction 2 weeks before Hurricane Harvey passed directly over the top of that reef. And it was really, you know, we didn't know what to expect. We thought we had just poured a whole bunch of money into the water and it was going to be gone. But when we were finally able to get back out there, which was about a month later, not only was the reef still there, but the reef was totally wrapped up in larval oyster spat. So those newly settled oysters were all over the reef. And so there was an indication that, you know, the low salinity that was caused by that hurricane induced oysters in the bay to spawn, and that those larval oysters needed a place to attach, and they attached onto that reef. So they are, you know, if you build them with resilience in mind, they really do a very nice job. And those areas of the coast were also protected by the reef being there. If I have 5 more seconds, what I wanted to say, one more thing is, somebody had asked about the hempcrete, and I just wanted to also say that if somebody has interest in developing hemp products for oyster reef restoration, another thing that we've really been looking for is a mesh that can be used to enclose oyster shells for our community-based efforts, where we get volunteers to go out and restore oyster reefs by bagging up recycled oyster shells. And we've tested a number of biodegradable materials that just do not hold up to the heat and the grazing in the Gulf of Mexico. So maybe hemp is, we've never looked at hemp, but maybe that's an opportunity as well.
And then I would say thank you, Jennifer. I've learned a lot from you, and it's been really enjoyable being on the panel with you. Thank you.
You too. Thanks so much.
Thank you both. We have a little break now. We're going to come back and reconvene at 9:55 Central Time to talk about topic 2, eco-design and resilience for cities building.
Thank you, Chloe.
Thanks.
We can't hear the sound of the video. Still no sound for me.
Hello, Chloe. Can you hear me?
Nicolas?
Oh, yes. Yes.
Hello.
Yes. Hello, it's working. Great.
Perfect timing. Okay, so I will reintroduce us and start our next session here. So thank you, everyone. Please bring your attention back to the panel. Our next section is on topic 2, eco-design and resilience for city building. And our first panelist is Nicolas Vernoux-Thélot, who is an architect at In-Situ Architecture in France. So he has 10 minutes, and then we'll turn it over to our next 2 speakers for their introductory remarks, and then we'll have a lively interactive discussion between all the panelists. So I'm looking forward to that part as well. Nicolas, the floor is yours.
Thank you very much, Chloe. First, before introduction, let me check. I want to share my screen, and then I'm doing right now the sharing screen, and then here are the slides. Let me check. Yes, it's working. Can you see my screen? The sound is good?
We can.
Okay, great. So so my name is Nicolas Vernoux-Thélot. I'm a CEO of 2 firms, In-Situ Architecture and In-Situ Lab. In-Situ Architecture develops architectural projects, and In-Situ Lab develop research, biomimicry, and innovation in a partnership, exclusive partnership with CNRS RDP. CNRS is the National Center of Research and Science in France, and laboratory RDP is research development of plants. We work on several projects. Let's write slide 2. We work on several projects such as optimizing recycled structures, bio-inspired natural ventilation, thermoreactive facade system, biorecycled material, and phyllotaxic algorithm. I would like to focus on the last program, the phyllotaxic algorithm. So what is phyllotaxy? Philo Greek is the plant, and taxon is the arrangement, the organization. These biological models show the spatial organization of plants. In most cases, the leaves of a plant are distributed in a spiral organization. This organization ensures to the leaves an optimal exposure to sunlight. Thanks to the development of computing, biologists have been able to model this spatial organization as shown in the diagram of the slide. This spatial arrangement follows a geometric pattern, which is in most of the case a logarithmic spiral. This geometric pattern is found at several scales of the plant. For example, the slides show a zoom on a Romanesco cabbage, a daisy flower, and a pineapple meristem, viewed in an electronic microscope. So this is macro and micro, as you can see on the slide. We focus on this geometric organization because plants are efficient in terms of footprint and ecological resilience, whereas a building is the opposite. It's creating a lot of pollution. I would like to say it's toxic. I want to remind that the goal of the biomimetic approach in architecture is to optimize resources and energy. The challenge is to use biological models to translate them into architecture to promote sustainable and ecological solution. So transposing this spiral organization into building design is interesting for the capture of sunlight and its optimization, because sunlight is a source of energy and has at least 2 benefits. First benefit is benefits for health and the regulation of our biorhythm. Second benefit, has a source of passive energy for the building. Direct sunlight can reduce the heating needs of a building, as everybody knows, or has everybody already experienced. So let's see how it works with an algorithm. Here is a video, a small video of the calculation of this algorithm. So we transpose the spiral organization of the plant to an algorithm who did the same with cellule for habitation. And so the geometric patterns, we transpose it to an architectural organization. And this generates building templates. So the interest of this approach, as you can see here, is the search for the density, which is one of the main challenges of the city of tomorrow. I mean, if we just have very few buildings, then we can catch very easy the sun of the sunshine. I mean, to get the heat of the sunshine. But when you're looking for density, which we want to do because it's the issue of the city for tomorrow, so we need algorithm to calculate the complexity of the light during winter and during different seasons, and to get a maximum of density, as you can see right now here. Again, it's not a design. Again, it's just templates. So the algorithm is not creating a project. It's creating volumes, implementation from who design can start. So this point is very important. So I think the video is almost yes, finished, and then we can see all the hours on the elevation on the facade of the templates, how many hours we can catch the maximum on all the building, and you can see here. Yes. So after this presentation of the algorithm, let's focus on one project, a project named Eco District in New Aquitania. It's in France. So this project takes place in South France. As you can see, it's close to Bordeaux. The site is an area of 130 hectares, and the site is a forest of maritime pines. And this forest is surrounded of individual house and housing. It's a sort of small forest in a urban context with all the facilities and close to all equipment required for working, schooling, eating, and sleeping. So it's a very good position for this site. So we analyzed the environmental constraint. And so we have 8,366 trees, pines, most of them pines. When we analyze the cycle of oxygen and carbon, and we have 1,700 tons and 70 tons for carbon. For the sun, we have 160 million kilowatt per hours, and the precipitation is 417 cubic. The evapotranspiration is about 70%. Infiltration will be 20%, and evacuation, when I mean evacuation, I mean stream by stream, is about 10%. The wind, the dominant one, is coming from west, like on the slide. So let's apply the algorithm tool to this site. But this time we have this forest of trees. And so we want to keep these trees, the maximum of trees, and it will be interesting for two reasons. Because of course we can preserve the biodiversity and the ecosystem which pre-exist. And we can also avoid the heat during the summer. So we would like to catch, with this tool, we can calculate how to catch the sunlight for the heat of the building. And we would like to also to keep some trees to refresh building during summer. So that's why on this algorithm, it's a mix of building and trees. At the end, we have this sort of axonometric view, aerial view, and then the resulting urbanism defends an ecological approach that conceives building as a non-invasive species in equilibrium with the pre-existing ecosystem. So this approach is very different than the regular approach, which consists to get the road and then make the building with the road. In this case, we have this ecosystem, we have the trees, and we will design the building as plants, of course, of a new plants going into the ecosystem. Of course, these new plants will impact the ecosystem, but it's not an invasive species, because usually when we plan urban system, then we plant from scratch. Most of the time, vegetation, plants, everything are just down, and then we rebuild everything. In this case, we try to have the building in between the trees and to keep all the trees, and we can keep, with the algorithm, we can keep 40% of the biodiversity and the trees. Here is a aerial view of the project, the result of the project, and this is a detail of the building and the different activity. We can also mix habitation, working, schooling, eating, and commerce, of course. So the conclusion, and I will finish with this. This project posed the following general problem: how to develop the city and its land reserves while fighting against climate change, which require it to preserve nature and existing biodiversity. Our response consists in creating a biomimetic district which implements a development whose ecological balance is equivalent to that of nature. Concretely, the road network, the footprint, and the building, the open spaces, are dimensioned by the study of the existing ecosystem and its resilient capacity to integrate building. Thank you for your attention.
Merci beaucoup, Nicolas. I was thinking I don't actually see a lot of pine trees used in urban design, so maybe we'll get some of those in New York, which would be lovely. Moving right along, our next speaker is Eduardo Blanco, who is a PhD candidate at CEEBIOS, France. Eduardo, you have the floor.
Hi, everyone. Thank you very much. I'm just sharing my screen. Can you see it? So everything's fine?
We can.
Great. So I'm Eduardo Blanco. I'm CEEBIOS. So CEEBIOS is a French institution working and catalyzing biomimicry here in France. So here I'm a project lead on regenerative design and biomimicry applied to urban design, and also a PhD candidate at between CEEBIOS and the French Natural History Museum here in Paris. And today I'm going to talk a little bit about the work that we're doing here in CEEBIOS to catalyze development of biomimicry in France and how it's happening, and also give some insights from the sciencey perspective about the work that's happening here. So since 2 years ago, CEEBIOS is organizing a working group with architects, real estate developers, and other city builders, stakeholders that are interested by biomimicry. Nicolas is a member for sure of this working group that's called the Biomimicry City Lab. Our first work that we did, and we finished it in last January, was to identify some key projects that were designed and using a biomimetic approach here in France or by French designing teams, and to write some fact sheets about them, to describe how these projects are tackling climate change, biodiversity problems, using biomimicry, to give some transparency to this kind of information that is actually hard to find, and to create some kind of document, communication document, to raise our awareness on the topic, on the stakeholders of the city fabric here in France. So it was a document that was done in a collaborative way. So each design team contributed with its fact sheets, and we worked with 16 different projects. So here we have, it's a small sample of the biomimetic projects that are happening in France. Some of them are conceptual, they never reached implementation phase, and we have some projects that reach an implementation phase, so they're more developed. And so it's a very nice document. It's only in French by now. You can find the document at CEEBIOS website. It's ceebios.com, easily to find. And you can find all detailed information about these projects. To move a little forward and to draw some insights from this document, we advanced with scientific article, analyzing these projects to understand some main characteristics of these projects. But today I'm going just to discuss 3 topics. At first, what was the objective of these projects when they tried to apply biomimicry in this urban project? So to this first question, we found that we always have this notion of sustainability or generative design behind the motivation. So we are going to find projects mostly addressing questions as thermal comfort. That's a very important question in terms of climate change. The second topic that was really highlighted in our sample was project trying to integrate biodiversity. I believe that it joins the presentation of Nicolas, this problem of how to integrate human development with the development of other species that live with us in this earth. So many projects are using biomimetics and living systems, learning from living systems to integrate biodiversity. The other two topics that I would like to highlight, so it's climate change adaptation, so how to adapt and to be resilient facing all these changes that's happening, and visual and light comfort. The second topic that we explored was which are the models that design teams are using today when they try to apply biomimicry here in France. We found that mostly we are having macroscopic models. So at first we have plant ecosystems, so that are something that are large enough and can be easily compared to systems that are also ecosystems. We have plant models and animal models, but we almost didn't find microscopic models, so small models. It shows us some bias in the choice of models when we are applying biomimicry. We know that we have a large diversity of models that are microscopic, but we're not used to look for them for inspiration yet, even if they hold a great opportunity of innovation for sustainability also. And finally, the third topic that we explored was the challenge that these design teams are facing to integrate biomimetics in their projects. And there are two main challenges that we found, and we discussed it a little bit, and we are working with this topic today. That's the different temporalities between project design and research and development. So several teams have this problem. They need to design a project. Sometimes they have very short delays to do that. And to apply a biomimetic innovation, they need research and development. So sometimes they don't have this timing it's some kind of, there are some incompatibilities. And so they're trained today to start to partnerships with research institutions or to join research programs, as Nicolas also is doing for sure. And the second topic is regarding the team knowledge and composition. So they also highlighted the importance to have biologists, ecologists, team members that have knowledge in these fields of living systems to facilitate the navigation between this knowledge from the biological sciences to the urban design sciences. So it's important to integrate them in early phases of the design process to better integrate biomimicry into the projects. So it was our main three results of our study. This study, differently from the original document, is available in English, also in the CEEBIOS website, and you can check it out to have all the detailed information. I will not take more time, and I will stop here.
Eduardo, thank you so much for that. CEEBIOS rather than CEEBIOS, am I correct?
Yeah, in French, it's CEEBIOS. So,
okay. So CEEBIOS for our American audience then. Thank you very much for that, and we will discuss further during the Q&A period, but I'd like to move right along and give the floor to Karim Selouane, who is an entrepreneur at Vinci in France. Karim? Karim, you're muted.
Yes, do you hear me?
We can hear you and we can see your slides.
Okay, perfect. Full screen, yes. My name is Karim Selouane. Donc, I'm proud today to introduce you a collective work that it was launched by the Alliance HQE, dedicated to support and to accompany the real estate and construction industry to integrate the resilience methodology and adaptation solution for building. In fact, the building can be vulnerable to climate change. In the future, there may be an increase in the risk of collapse, declining state of significant loss of values as a result of more storm, for example, snow or subsidence damage, water encroachment, deteriorating indoor climates, and reduced building lifetime. For example, in the European Commission in France aims to increase the climate resilience of infrastructure, including building. New existing building needs to be assessed for resilience to current risk and future climate change and planned or upgraded accordingly. In fact, in this picture, for example, cities and infrastructure are facing shocks and stress due to climate change. And one big information is the cost. For the adaptation will cost around, this is an average estimation, 18 or 100 billion per year and will be borne by urban area. That's why.
Karim, I hate to interrupt you, but can we just ask you to go into presenter mode? We've had a couple of requests so that we can read your great slides.
Do you see the slide or not?
We see the slide, but can you enter presenter mode?
Yes, normally. Like this?
Yes.
Okay, sorry. Okay, yep.
Still not
here.
I'm still seeing regular.
Okay, perfect. That's why we propose a definition framework.
Now we see your Word document.
What do you see now?
Your Word document. Your
okay. Okay, perhaps this one?
No. Now we see the side by side.
And here?
Side by side. Uh-oh.
Oh la la. Sorry.
Let's click diaporama.
Yes.
It should be playing.
Do you see the full screen or not?
The computer screen, but we see the slides. All
slide
the slides.
By slide.
Yeah.
Okay, we will stay like this, okay?
I think that's the best choice.
Okay, thank you. Well, we try to define the framework for climate change resilience and adaptation in the built environment. For example, here you could divide the approach into 3 parts. The first part is, first of all, to project information, after to determine the climate parameters, to define the climate hazard, to evaluate, for example, the best scale than the neighborhood resilience to hazard. The second step in the blue color here, this is three key points. First of all, the neighborhood assets, to determine after the neighborhood risk and the projection of the risk. The last step is how we could match, for example, the adaptation goals with the adaptation strategy, and also how we could match the mitigation and sustainability goals with the mitigation and sustainability strategy. In the end, the objective, the final objective, is to integrate the evaluation of the strategy to reduce the risk and to propose a new design for reinforce the resilience and the adaptive solution for the building. That's why we summarize this approach into 5 domains, could be divided into 15 levers. First of all, the planning services and territorial cooperation. First point, design, the planning and regulation, continuity of services and degraded modes, territorial cooperation with the several stakeholders, policymakers and public and private sectors. Second point, studies and ecological diagnosis in the site. For example, how we could define the best field to diagnosis. For example, the sanitary, the access of energy, etc. Second point, studies and knowledge of the impact, how we could support the population, the community, to integrate the climate risks, for example. And the last point is the water and the nature-based solution, because it's very low carbon solution, for example. The third point, urban form and structures of components, very important here, design option and construction method for building integrity, adaptability and versatility. This is 2 ways to design a new building, for example, how, without to destroy a building, how we could rethink a building, how we could redesign the inside, the uses of the building, for example, and the nature-based solution and the bioclimatic design architecture, as we saw just before. The first step is health and comfort for all. For example, in urban heat island, how we could support the next heat wave, for example, limitation of nuisance and pollution, cooling solution, accessibility. And the last point is the uses and the behavior, because you know the capacity for the technical solution to reduce the risk presents several limits, cost limits, the technical limits. That's why the big part of the adaptation solution could be from the behavior and the uses. Mutualization of shared space, for example, evacuation and shelter area, on knowledge and information. That's all, and thank you very much.
Thank you very much, Karim. So we'll move on to the discussion portion here, and I'm glad we have a little bit of time to hear from all 3 of you. So I'm going to pose a number of questions, and I'd like all of you to answer. But of course, if we have questions from the audience, we will take those as well. So my first question is, what seems to be the main challenge to integrate some of these ideas and concepts of biomimicry into sustainable architecture and urban design projects today? You know, there are obviously a number of challenges, but I'd like to hear from your perspective what you think is the worst challenge. Nicolas, why don't we start with you?
Thank you for this question. I mean, the main challenge is let's say the firm already have an organization, and all the materials, the production of the materials have an organization, and you can't really change it like this. When we're talking about biomimicry, we're talking about innovation, and innovation means different method, different way, different materials, and all the firms, general contractor, I'm talking about general contractor, they can't really get the innovation like this. So they need a lot of time to integrate this innovation, and it takes time. It's like a big boat. I mean, the building process is like a super huge big boat, and you want to turn on right or to turn on left. Well, it won't turn in one day. it will turn in it takes a lot of time to turn. So I think that's the main challenge right now.
Yeah, I would agree with that. Change is so difficult for organizations. In our work, we see that, you know, the advantage of any sort of disaster situation, obviously mostly they're terrible, but the one advantage you have is that change is forced on everybody. So there's an opportunity for that. Eduardo?
Yeah, I fully agree with Nicolas. I believe there are challenges in the design still. Some designing teams, they are not used to design using biomimicry. They don't know the concept, they don't know how to do, they know the methods, but there is a huge problem with the innovation side, because teams, they are usually, they request a proof of concept. Is this going to work? Is this, we have some documentation. Is this innovation going to be financial viable in my project? So all the innovation side, the lack of huge and large and wide experimentation, it's a quite hard challenge in the field.
Karim, what about you?
For me, the big challenge is the capacity to anticipate the several scenarios of climate change, because the solution for today is the condition of today. It could be the good condition for the next decade, for example. And this is a big uncertainty. And this gap is a big challenge, how we could reduce the gap, so to assume the probability that the choice of today will be the best choice for tomorrow. For me, it's the big challenge.
We're sort of living with some of those consequences today, the consequences of yesterday's decisions, certainly. So of course, we think we know more now, but we will certainly make mistakes that future generations will look back on and laugh or cry. We have a question from the audience sort of building on this. We talked a lot about some of the organic challenges, but this individual is curious to hear how existing building codes, current urban zoning and policies may hinder or promote this effort. Does somebody want to jump in on that one?
I can jump.
Please.
Yeah, it's. I would say that it's also a challenge. There are a lot of barriers and challenges regarding existing policies and codes in cities that avoid, even if cities, they have innovation strategies, sometimes the building codes, they don't allow innovation. So we need really to work close to public policy actors to try to make these codes evolve. I believe that the Living Building Challenge, the label that's also had some biomimetic inspiration and insights, they had this problem with the Build Center project. They wanted to apply several innovations regarding water cycling and water autonomy, reusing water, rainwater, and they had problems. And they did a lot of negotiation with the public actors to change the codes. And after a few years, they achieved its goal to make the policies evolve with the project. So interesting negotiation, and I believe today there are more challenges, but there are opportunities of evolution.
Yeah, I've certainly seen this as well in my experience, where sometimes the new ideas, the next idea just does not fit into the code. So if you have somebody who has to apply the code, you have a lot of problems. And certainly in terms of improving our resilience, we see a lot of challenge in this regard. I don't know if either of the other panelists wanted to expand on that a little bit. We actually have a question that just came in directly for Nicolas, so maybe we'll jump to that one, which is, do we understand that the algorithm is parametrized to optimize sun exposure, and are there plans to include multivariate parametrization, for instance, to include optimization for hydrological services?
Yes, very good question. Thank you for this question. Yes, it's a parametric about catching the sunlight, and then it can be multi-parametric. So we first design the question of the sunlight because we have this issue with the heat, and we know, just to let you know, with our calculation, we're talking about saving 20 to 50% of the consumption of the heat of a building. I mean, it's huge. And we're just talking about geometric, like making building with this geometric, then we will save 20 to 50% of the consummation of a building, which is very important. So we can add different other parameters to the algorithm, like wind, because wind can be interesting also for refreshing buildings, and noise also, and a lot of parametric. But at this time, as you can see, we had a sort of first beta version that I show on the slide, and then we integrate trees on the site. So with different projects, we have evolution with this algorithm, and then we plan to integrate other parametric constraints to the algorithm.
Well, that work will be very useful. We just saw an example of how you can fix this process right now, because I'm based in New York City and a motorcycle went by, and so Zoom picked up my microphone momentarily instead of yours. So maybe your project would actually help to protect us further. We have another question from the audience, which is, in the Gulf, the pressure to build back the same rather than with more resilience after hurricanes or floods seems to prevail. Is that the same in France, and how do we change the paradigms? Karim, maybe we can start with you.
Yes, can I jump? Yes. I think at this stage, the only factors to change these paradigms is from the financial consequences. That's why, for example, in France, insurance, for example, decide to refuse to cover your insurance if you don't respect some design to anticipate a severe natural risk or some climate events. But I think the best way to change or to disrupt the paradigm is to follow, for example, some financial consequences. That's why the rate agency or the insurance impose more and more to integrate the resilience during all life cycle of project, from building, from design, construction, and during the operation of the building.
Yes, and France is actually a leader in this in terms of climate-related financial disclosures and requiring those, or getting companies to disclose what their risk is. We're certainly not there in the US, although there is some drive to make that happen. But perhaps we will follow your example.
Yes, but perhaps I remember in 2019 the Moody's decided to refuse to evaluate the quotation of the north of the several cities in the eastern coast. Yes. And if you remember, during the last July, the several insurance refused to cover some building in Florida.
Yeah, so we take the private sector-led approach with the insurance and the ratings agencies trying to promote pressure rather than the unified governmental pressure. So we will see which approach works the best and continue with a lively debate on that discussion. We only have a couple more minutes, so I wanted to say that we're looking at resilience and protection and safety, but something that's also important as we look to the growing urban population. More people live in cities than anywhere else. How do these projects also improve livability? Can each of you speak for just maybe like a minute or 30 seconds about how your projects promote urban livability as well?
So what do you mean by, Chloe, sorry, what do you mean by livability?
Livability, oh yes, this is a funny word, isn't it? Promoting or improving the quality of life in the city.
Well, if I may first, because the presentation and what I say is that the question for the city for tomorrow is the density. We know that all cities have to grow, and then also in the meantime we have to keep the biodiversity. So how making city growing, so more density, and keep in the meantime the biodiversity of plants, of nature, of all the environment. So it's a real issue. I mean, so the project, the new approach, urbanism approach that I present, that I promote is about mixing biodiversity plants and buildings. And so I think it's a good way to answer to your question for better quality for living. For a new site, I mean, it's very easy, of course. So now you have the question of the rehabilitation. When you already have buildings in city, and when you have to make this city growing, how will you do? So I think the question of, and maybe Karim talk about this, the NBS, like nature-based solution. Yeah. I think it can be a real answer because we have to mix nature-based solution to building and also creating density.
Karim, did you want to jump in there? Maybe 30 seconds.
Yes, rapidly. Yes, rapidly. The question of nature-based solution or the preservation of the biodiversity, it's a conflict, a balance of power between the cities, the density of cities, and the necessity to protect the country, for example, because all people now are looking for the very big space with the nature. But if each people is looking for nature, the place with the nature, there is a contradiction between how we need to because we need to preserve the nature, but also people want to live in the nature. How we could negotiate to find a good balance between the necessity to decrease the density in the city, for example, and in the same time to preserve the country.
Yeah, it's a difficult challenge. We certainly see this with wildfires, with people moving further and further out and wanting to live in nature, but then you have a problem with the wildfires increasing. Thank you all for that excellent panel. I think that's all we have time for. We do have to move on, but I so appreciated this discussion. Merci beaucoup.
Oh, merci.
Thank you very much. Moving on to topic number 3, which is innovative and socioeconomic solutions for climate resilience. I think we'll find it's very much related to what we were discussing. Our next panelist is Ulsia Urea Marino, who is a graduate research assistant at Harte Research Institute in the USA. Ulsia, you have the floor.
Thank you very much. So, I will share my screen. Please. The presenter view. Can you see it?
Yes, we can see your slides.
Okay, thank you. Thank you very much for the space. Yes, I am Ulsia Urea Marino, and I'm part of the socioeconomic groups. And the presentation is entitled Coastal Cities Socio-Ecosystems System Challenges and Opportunities in the Face of Climate Change. I want to address that this presentation is based on my dissertation Perspectives Advanced, but also I want to highlight the importance of coastal cities around the world, and especially for the Gulf of Mexico, because we know that the climate change is a fact, but we know that also that the effects of climate change, even when the whole population face it, we don't face at the same time, and the same frequency of the events, and not as harsh as other places in the world. So it's important to notice that, because the urban population is increasing, and is in 2018, 4.2 billion of world's population reside in urban areas, and it's expected that in 2050, 68% of the world's population is projected in urban areas. So we now live most of the population in urban areas, and in coastal areas, especially for coastal plains as Gulf of Mexico. That means places in which we don't have high lands or mountains near to the coastal areas, when even only represented 2% of the total land area. In 2011, represents the 13% of the world urban population within that area. So it's important because in a very small piece of land, there are a bunch of people that live and face the climate change especially hard for the hydrometeorological events. So state that climate cities hazard taxonomy, it's not only for coastal cities, but it's thinking about how the climate change could change our ways in which we can relate it with the urban spaces. So this is a very easy way to understand that with meteorological changes that are in the short term, instead of climatological one that is in the long-term changes, especially for the urban areas in coastal zones, climatological and hydrometeorological changes are important. And hydrometeorological, we have storm surge, hurricanes, floods, and sea level rise that are important for this part of the population. Geophysical are important and related more with how the land is displayed after a hydrometeorological event, for example, a tropical storm or a hurricane. And the biological, as the colleagues mentioned in the previous presentation, are related with the biodiversity and, for example, exotic species in areas, especially in coastal areas for harbor. And we know that now there are plenty adaptation and mitigation actions that maybe we can take place in cities. But one of the stuff that are moving slow with this adaptation and mitigation action is how the planning or the urban planners could introduce these spread efforts and very academic ones in some cases in the real world and in the real cities. And for this, we need to think that the advances of the science sometimes take some long time to be reflected in the reality. So we need to think in which are these instruments, and that my colleagues mentioned before, in which we can reflect this adaptation and mitigation actions. In case of the socio-ecological system, which is the framework that I want to achieve, is to realize first that the humans and the physical and biophysical environmental are not separated. We are part of the same system, and for that reason it's very complex. And we have tools that we can use it to achieve this goal. So, for example, we have three categories of instruments in urban planning to address that. The first one is the planning instruments itself that are related with how we can plan the land in which we live. And this is a variety of the planning and scales and times, but at the end of the day is how we can manage the territory. The second kind of category is the management instruments, in which we reflect how we can manage the city. And we can divide it in different frameworks. For example, they are the framework of the hazard and risk management. And also there are specifically some management related with the climate change. Now, this is kind of new category, but in the world is like every day we need more that this kind of instruments of management. And finally, we have the financing instruments, because if we don't have the money and resources that we need to achieve that goal, to build something or restore an ecosystem that is in damage, we can achieve in the reality these objectives of adaptation and mitigation. And for that reason, if we integrate this vision that this complex system, the relationship between the nature system and the human population and dynamics, we can see or we can achieve in a fully, completely our intention to adaptate or mitigate to climate change. So for this, I think that to be only clear with what is refers to the socio-ecological system, it's it's an arbitrary concept in which you can relate some specific territory with some specific human population and how or determine what is the interaction that they have. So for this reason, I think we can consider the cities, and each city is different itself, that how we can recognize this relationship between the population, the human population, and the environmental, and delimitate in a boundary, in a real territorial boundary, the socio-ecological system, and based on that, generate information or to be addressed or to be feeding these urban instruments that take in account this complex relationship, but at the end of the day, the objective is to have a better relationship with the environmental, but also with the humans that live in that area. So with that, I conclude my presentation, and thank you for the space again.
Thank you so much, Ulsia. That was a very enlightening presentation, and I'm glad we're talking a little bit more about the mitigation side as well as adaptation, because of course the answer is a combination of the two, and we certainly need both. They're very important. So we're going to talk even more about the mitigation side, moving on to Jim Blackburn, who is a professor at Baker Institute at Rice University in the US. Jim, you have the floor.
Yep, thank you, Chloe. And I guess in many respects, I want to talk about essentially biomimicry, where we try to adapt the economic system to the ecological system and try to bring it more into consistency with that. I want to talk about a process that we've developed at the Baker Institute at Rice for paying landowners to sequester carbon dioxide in their soil. And potentially this could be expanded. I mean, there's quite a robust forest market in the world right now, but we have, I think, a unique aspect of forest, and also potentially to oysters, which might tie back to some of the earlier work. But what I would say is that at Baker Institute, we realized that there was a problem with the international system of carbon payments for carbon sequestration by nature. In our opinion, we talked with a lot of landowners on the Texas coast to try to get them interested in participating in the clean development mechanism systems that come out of the Kyoto Protocol of 1997. And none of them were interested in participating. The hurdles for participation were too high. And we figured that there was a huge opportunity that was being essentially omitted in the United States. And so we went about at the Baker Institute, we formed a stakeholder group back in November of 2019, right before the pandemic hit. And all during the pandemic, we have been operating a stakeholder group via Zoom. And we have developed essentially a carbon standard we call B carbon, which I'll talk a little bit about. And I think probably more importantly, we did it with a stakeholder group that now numbers over 200 people. By the way, anybody listening can become a member of the stakeholder group. We invite participation. You can reach me at Rice University, and my email address, they only gave me 8 letters, so I am blackburr@rice.edu. But if you're interested, please join us and you can listen in or participate as much as you want to. Now, nature-based carbon capture and storage can be of many different types. Some are valid, some are bogus. The range of prices goes from $5 a ton in the United States to now we're getting well up beyond $20, $25 a ton for the voluntary market. There are credits that are given for avoided conversion of standing carbon, forest. We do not offer credits for that. There are credits that are given for changes in agricultural practices. I think there is some validity to this, perhaps not as much as some think, but we don't give credits for that. We only give credit for measured removal and storage of carbon dioxide in the soil. And so we are most concerned about the fact that carbon dioxide actually gets removed and stored in the year in which the transaction is approved. We call this fresh carbon. This is carbon that is removed and stored in the year of the transaction. We require through B Carbon a very rigorous measurement system to create both a baseline and then a follow-up analysis to confirm the amount of carbon dioxide that was placed in the soil. B Carbon was formed as a nonprofit institution. B Carbon is awarding credits. At the current time, we are processing our first 75,000 tons of carbon dioxide credits. B Carbon basically became operative in June of 2021. We have 50,000 credits by an oil company, another Marathon Oil, another 10,000 credits by Shopify, an e-commerce company from Canada. And we're working with partners in the United Kingdom in Yorkshire for another 10,000 tons to be applied to creating carbon neutral beer. I think you're going to see this market absolutely explode. There is interest coming from all different directions of all aspects of the supply chain. And there is more and more pressure being applied by lenders that various entrepreneurial activities have not only a carbon plan, but a carbon removal plan associated with their associated with financing, for example, ventures that might last 10, 20, 30 years into the future. The change that has occurred in thinking in the last 18 months in the United States, and particularly in Houston, which is by most people's description, the oil and gas capital of the world in many respects. And we have gone from virtually not talking about this publicly, and certainly not in polite social conversation. I've been talking about it for a long time, but I don't get invited to many parties. The issue is now front and center on everyone's mind, and you're going to see major changes coming out of the oil and gas industry, as well as many other industries in the United States in the next 6 months. I would be very surprised if there hasn't been a major announcement by every major oil company in the next 6 months that's transformative in terms of their way of doing business. And carbon capture is going to be a huge part of it, as well as any number of other companies. The system that we have set up is about scale. This is a scalable alternative, but it has to work for landowners in the United States. If it doesn't work for landowners, it's not going to be good. This is an image that shows in yellow the grasslands of the United States, and in brown the food production areas of the United States, the commercial agriculture areas. What's important about this graph is the red circle. It's kind of the heartland of productivity. It's the heartland from rainfall and soil types converging. This is probably some of the best of the lands in the United States for purposes of grassland production. These are the old prairies of the United States. There are also, many of them are running out of water. Groundwater supplies are running short, and grasslands don't require irrigation. And so the conversion back to grasslands, there's 200 million acres in the United States that's dedicated to growing grain and corn for beef, for cattle feeding, and for other types of feeding operations. All of those are perfect to be converted back into grasslands and into carbon sequestration. So the potential for scale is huge. If you add to that potential for ecologically managed forests, and by that I mean forests that are managed to remove certain of the carbon that is being sequestered so that you can reduce the potential for fire, or even using fire as a management tool in forests to minimize in the long term the highly destructive wildfires that are so prevalent now in the Western United States. Most of the carbon concepts do not recognize ecological management, and frankly don't recognize fire as a management tool, which I think is a mistake. And probably most excitingly to me, I'm a Texas coastal person, and oyster reefs are among my favorite places on the coast. I fish, I enjoy oysters, and hopefully working with Harte Research Institute and Larry McKinney, we can figure out how to create a credit for the calcium carbonate that is formed by oysters and the carbon sequestration associated with creation of new oyster reefs. I think the point of all of this is that the economic system has a challenge in front of it to correctly reflect nature's values. It's interesting in talking with, for example, the oil and gas industry, they've never really thought of nature as a solution. They always go to technology. They always go to pumps and pipes and various types of technologies. And nature has the potential to be a major part of the solution for climate. But we've got to conform the economic system, and we've got to conform the economic signals to frankly let the market loose and to reach scale. But we think there's certainly a couple of billion tons of nature-based carbon storage that's available, and could provide up to a third of the United States footprint removal. So it is a very large potential part of a portfolio of options to address climate. And with that, Chloe, I think I'll close and be happy to take any questions.
Well, thank you so much for that, Jim. I'm excited to see that we're already seeing potential synergies between our panelists and new ideas coming out of this, which I think is exactly the purpose of hosting events like this. So I'm personally thrilled about that. I wanted to go back for a minute to Ulsia to ask a question related to your presentation, which is which cities have been selected for the study? And one of the things that I think is very valuable, as we've seen, is making comparisons between different projects in different regions. So is it possible, from your perspective, to compare the cities from different countries? Is that happening anywhere? How is that useful?
Thank you, Chloe. Yes, at this moment, we don't select any city, but we are thinking to compare for this specific project cities from Mexico, Cuba, and US, because we are the countries that are surrounded the Gulf of Mexico. So based on we share a common ecosystem or marine grade ecosystem, and how face the same challenge that is the climate change, especially sea level rise. We did three very different approaches since the administrative and political ones. So I think for me, it's very exciting to do that. And yes, it's possible to compare how very different cities act to do this. I know cases, for example, in case of tourism, they compare what is the economical base to develop economical activities in the cities, even when they are in the different countries. But for this specific topic that is the climate change, I don't know exactly a case of in which they compare cities for different countries. They compare especially in the same country. But I think, again, because it's a global challenge that we need to tackle, we need to think, I think, outside of the box, only to share with our equals or similars. I think it's rich to see how another very different approach do the same thing, and I think it's valuable to try to do that.
Certainly we have to work together across country lines. I know there's been some interesting work between Mexico and the US, as you mentioned. It's not so much climate change related, but resilience related. Certainly there has been conversation between, for example, Los Angeles and Mexico City about earthquake preparedness, because they face very similar challenges. They're massive urban sprawl, they're very, very large metropolitan areas that are very car dependent. So I know they've had some really productive city to city conversations, which is great for the cities to be talking, as well as the countries to be talking at that larger level. So I'm sure we'll see more of it. Jim, you brought us back to the Kyoto Protocol, which it's been a while since I've talked about Kyoto, but that really is the place where a lot of this conversation started. So why did you think it was necessary to develop a standard that was different from those based on the mechanisms that were created back then? And how does this improve on that system that was founded at that time?
Well, I think that the origin of the Kyoto-based clean development mechanism standards were really transactions among countries. And so much of what we're interested in is getting private landowners to participate. Many of our landowners are good stewards. They have been for example, in the recent past. I think many are going to better management practices. They would be eliminated from consideration under some of the restrictions that are out there. Our position is if you test and then can prove that you're increasing your carbon, that you ought to be able to sell, regardless of what you were doing the year before or 10 years before, for that matter. There's also limitations. For example, if you're already making if you're already financially secure, if, for example, you're ranching and making money off of ranching, you may not qualify because you don't meet the financial test. There is a test that requires that if 25% of your neighbors are using similar practices, you may not qualify. All of these we feel like are just barriers to creating a market. We want to make it easy for landowners. So we have simply said, if you put carbon in the ground and can prove it, we will allow you to have a transaction. And we also require that it stay for a minimum of 10 years, with each year's transaction renewing the 10-year requirement. That we have found will work for most United States landowners. And if we can't get the landowners to participate, then we're not going to have a program. That was kind of where we were coming from, is that we wanted to make it easy to qualify. The buyers told us what they needed was credibility of the credit, and that was testing. And so the rigor of our approach is in the testing. The expense of our approach is in the testing. And that will be reflected in the price of the credit. That we felt like was the right balance to reach. It's a different balance than is in the current standard. Our approach to additionality, which is a kind of a critical concept, is different. We only need to prove that our carbon has been added in the year in which it is transacted.
So you brought up affordability and buying into these sorts of programs, which is related to some comments that we're getting in from one of our audience members, which are related to the equity question, right? So much of the effects of climate change are borne by those in our society who are most vulnerable. Affordable housing units are often built in floodplains, for example, and they're going to really feel this burden the most acutely and are probably the least equipped to be resilient and to be flexible. Do either of these programs, and either of you can jump in here, address the issue of equitability at all? Of equity, I should say.
Well, I'll happy to go first. We feel like by directly addressing climate change and removing carbon dioxide, we are addressing equity, because the statements you made is absolutely correct. Those that are least able to handle climate change are the ones that are with the lower income levels and are in the areas that are kind of poorly maintained. But we have a principle 11 for B carbon that is specifically directed for diversity, equity, and inclusion, to try to, among other things in this case, include the minority community, diverse ethnic groups, and land ownership. We're reaching out to African American owners, Hispanic owners, and indigenous Native American tribes and tribal lands to get them included in the B carbon program. So we have both an aggressive DEI function within B carbon, but generally we're addressing climate change by removing carbon dioxide, and we hopefully will increase that by 1 billion tons or more over time. So we feel like we're addressing kind of two aspects there.
That's wonderful, Jim. Ulsia, did you want to add anything here?
Yeah, but it's not related with the US case because I don't know much about it, but in Mexican case it's similar, but the problem is it's not only the case of Mexico, it's the case of most of the countries around the world, but it's the people can think and even act about climate change because they don't have the basics stuff that they need every day. And it's not it's not related only with the actions that the government will take place. It's even with questions with inequality and poverty, in which people can face the climate change as we understand the climate change because they don't have another skills or knowledge or resources to face in which we can think the climate change we can face. So I think it's this discussion, I think it's valuable, it's necessary, but we need to focus this in different kind of realities. And yeah, different kind of realities and programs that tackle first steps, the poverty or the inequality, emerge or try to achieve at the same time climate change goals that tackle this big issue and global problem that we face together.
Well, I think certainly we've unearthed so many challenges. We humans have a tendency to create big problems in our societies. And I'm so happy to have what has been somewhat more of an optimistic conversation, which is rare in my field, about potential solutions for how we can use nature and learn the lessons from nature to apply to hopefully combat some of the issues that we will be facing related to climate change. Ulsia and Jem, thank you so much for your presentations. So with that, I think we've reached the end of the panel piece of this, which has been just so illuminating and totally enlightening, moving from, talking about the oyster reefs, talking about innovations in cities, and then moving on to the biomimicry and the socioeconomic factors of changing carbon sequestration and dealing with some of these issues at the mitigation level. So I'm just thrilled with the conversation that we've had so far. And I want to thank you all for your tremendous expertise and explaining it in a way that was enlightening and encouraging, and also we were able to understand at a simple and accessible level what exactly you are doing and how you are helping to make all of our lives better. As a city dweller myself, who is directly in the path of potential effects of climate change, I am very grateful for your work.